That's when the James Webb Space Telescope entered the picture. Launched to explore the deepest corners of the cosmos, this telescope was not just another tool, it was a monumental leap in astronomical observation. Its design was unlike anything before it, equipped with a massive gold-coated mirror spanning over 6 meters, designed to collect faint light from the most distant and ancient parts of the universe. But while its main mission was to look at the origins of galaxies, stars, and possibly life itself, Webb was also assigned to unravel the secrets of our cosmic neighborhood, and Betelgeuse became one of its top priorities. Betelgeuse, with its unpredictable behavior, presented the perfect challenge. Was it dying? Was it preparing for a spectacular finale? Or was there something even more unusual happening? Scientists hoped that Webb, with its high-resolution infrared imaging, could provide answers that previous telescopes simply couldn't. They wanted to look beneath the star's outer layers and understand the forces shaping its chaotic brightness. When the first images arrived, scientists were astounded. Betelgeuse wasn't fading into darkness as many had feared. Instead, it looked more alive and dynamic than ever. The images revealed hot spots, massive swirling patterns, and plumes of gas and dust surrounding the star like smoke from a celestial fire. This wasn't the portrait of a star dying quietly. It was the image of a star undergoing violent internal changes. What they were witnessing was stellar mass ejection on a massive scale. Betelgeuse was violently throwing off material, creating huge clouds of gas and dust that shrouded it from view, causing the dimming that had puzzled astronomers for years. The drop in brightness wasn't the star itself fading, it was being obscured by its own debris. These clouds could extend billions of kilometers into space, a size so vast it's nearly impossible to comprehend. This revelation shattered previous assumptions. For decades, scientists had believed that when stars like Betelgeuse began to dim, it was a sign of imminent supernova. But the Webb data told a more complex and nuanced story. Betelgeuse wasn't dying, at least, not yet. It was in a turbulent, energetic phase, actively ejecting parts of itself into space, perhaps as part of a long prelude to its eventual explosion. The images showed that Betelgeuse's surface was highly dynamic, constantly changing with areas of brightness and dimness shifting across its vast body. This activity happens in cycles that could span months or even years. The hotspots, regions of higher temperature caused by convective currents within the star, were far more numerous and intense than previously imagined. These new observations turned Betelgeuse into what one astronomer called a cosmic battlefield. Imagine regions on the surface of a star, each larger than our entire solar system, heaving with eruptions, tossing off waves of plasma, and shifting shape in real time. It's a spectacle that until recently, no one had seen with such clarity. Even more intriguing was the discovery of unusual dust patterns forming in the material surrounding Betelgeuse. These dust clouds, made of elements like carbon, silicon, and iron, could eventually cool and clump together, becoming the raw material for new planets or even new solar systems. This means Betelgeuse isn't just ending its life, it's seeding the universe with the elements necessary for new beginnings. The James Webb Telescope didn't just photograph Betelgeuse, it peeled back layers of mystery. Every new data point brought with it a new puzzle, challenging old theories and forcing scientists to reconsider what we thought we knew about stellar evolution. It suggested that the final stage of a massive star's life could be far more chaotic and prolonged than previously believed. Some scientists now theorize that Betelgeuse might be in a rare transitional phase, perhaps teetering on the edge of collapse, or it could still have thousands of years left. Others believe that the star may enter a more stable period before the final, explosive end. The truth is, we simply don't know, and that's what makes it so exciting. The universe isn't a predictable machine. It's alive, full of surprises, and always more complex than our models suggest. What makes the Webb observations even more valuable is how they help us understand our own cosmic origins. Every atom of oxygen you breathe, every bit of carbon in your body, all were forged in the cores of ancient stars. When those stars exploded, they scattered these elements into space, eventually coming together to form planets, oceans, air, and life. So, watching Betelgeuse now, with its swirling chaos and clouds of material, is like watching history repeat itself. We are witnessing the very process that may have given rise to our own planet, our species, and perhaps countless other forms of life across the cosmos. The James Webb Telescope isn't just revealing the death of a star, it's reminding us of our deep connection to the universe. And Betelgeuse isn't just a spectacle, it's a laboratory in the sky. Studying its behavior in real time gives astronomers rare opportunities. If or when it does go supernova, the data gathered will offer unprecedented insights. From the distribution of heavy elements to the shockwaves generated by the explosion, everything about a supernova informs how galaxies grow, how stars are born, and how life may eventually emerge. The anticipation is real. If Betelgeuse were to explode, it would not pose any danger to Earth due to its distance, around 642 light-years away, but the light show would be incredible. The explosion would likely shine brighter than the full moon and remain visible for weeks, maybe months, before slowly fading away. It would be the brightest object in the night sky, a once-in-a-lifetime event for humanity. But perhaps the most profound aspect of the James Webb image is what it tells us about cosmic time. Stars live for millions, sometimes billions of years, and yet, we now have the technology to watch them in their final breaths. That means we are catching moments that are so rare, so fleeting, that it's as if the universe is whispering secrets to us, one image at a time. With Webb's capabilities, astronomers aren't just peering into the future, they're also looking deep into the past. Because of how light travels, observing a distant star means seeing it as it was hundreds or thousands of years ago. When we look at Betelgeuse, we're not seeing it as it is today, but as it was over 6 centuries ago. The explosion, if it has already occurred, might be on its way to us right now. That's part of the magic. The Webb telescope bridges time and space, letting us witness the grand life cycle of stars, the birth of galaxies, and the ingredients of life floating through interstellar clouds. Every pixel in its images is a story, every dot of light a mystery waiting to be solved. And this is only the beginning. Webb is still in its early stages. Future missions may focus on observing exoplanets, searching for atmospheres that hint at life, or studying black holes, neutron stars, and other extreme cosmic phenomena. The telescope has already captured jaw-dropping images of distant galaxies, stellar nurseries, and now, Betelgeuse, all with stunning clarity. But Betelgeuse will remain a favorite. Its unpredictable behavior ensures that scientists will keep watching, measuring its light, and waiting for the moment, if it ever comes, when the star finally collapses in on itself and bursts forth in a cosmic blaze. If and when it does, we'll be ready. Astronomy is not just about distant objects, it's about understanding ourselves, our place in the universe, and the forces that shape everything we know. Betelgeuse is a chapter in that story, a brilliant, blazing, chaotic chapter that continues to challenge and inspire. Thanks to the James Webb Space Telescope, we now see this star not as a distant red dot in the sky, but as a living, breathing entity, undergoing changes, facing its destiny, and in the process, teaching us lessons about life, death, and everything in between. The implications of this are enormous. From understanding how stars like Betelgeuse form and evolve to learning how their deaths enrich the galaxy with elements vital for life, every new discovery opens up new avenues of exploration. Betelgeuse is not just a star, it's a mirror into our own cosmic story. As we wait for more data, more images, and perhaps the most spectacular light show of our lifetime, we are reminded once again of how small yet connected we are in this vast, mysterious universe. Subscribe